Welcome back to the Deep Dive. Today, we're going to dig into a really interesting tool, maybe one you haven't heard much about, from Google Engineering. It's called Mangle. Our goal here is pretty simple. Cut through the jargon and really get to the core of why this language matters, especially if you're dealing with, complex data. We're basing this on its GitHub repository, trying to piece together the main ideas.
Yeah, and Mangle, well, fundamentally, it's an extension of another language called Datalog. Think of it as a pretty sophisticated way to bring different kinds of data together so you can represent it all and query it uniformly. It's really rooted in this idea of deductive database programming.
Deductive database programming.
Right.
Okay, so you define rules and the system figures out new facts.
Exactly. It deduces new information based on the facts and rules you give it. Super powerful for complex reasoning.
Right. Now, a lot of us know SQL for databases. So how does Datalog fit in? Is it similar?
That's a good comparison. Datalog is declarative, like SQL. You state what you want, not how to get it. It's sort of like relational calculus in spirit. But the really key difference, Datalog has built-in support for recursive rules.
Recursive rules.
Yeah. Think relationships defined by other relationships, even circular ones. That's something standard SQL struggles with quite a bit. It gets messy fast.
Okay, that recursion does sound like a potential game changer. So if Datalog already has that, why extend it? What does Mangle bring to the table?
Good question. Datalog is powerful, but maybe a bit academic for some uses. Mangle adds features to make it more practical, more of a real-world tool. Things like aggregation, summing things up, counting. Also the ability to make external function calls.
So you can connect it to other code.
Precisely. And it adds optional type checking, which helps catch errors, makes it more robust. Now, there's a trade-off. These practical features, they can mean you sometimes lose some of Datalog's nice theoretical properties, like always knowing if a query will finish.
Guaranteed termination. Okay, so you lose that guarantee sometimes.
Potentially, yes. With things like external function calls, it's possible. It adds flexibility, but you need to be, mindful of it.
When is that trade-off worth it? How do people use it in practice?
It really depends on the problem. Often that extra power is exactly what you need. Let's take a concrete example like the log4j vulnerability. Everyone remembers that headache. Okay, so in Mangle, you could write a rule, something like this. Projects with vulnerable log4jp, a log4jp, OPP ups, contains jarp log4j version 2.1 sim.1, version 2.12.4, version 2.3.2.
Okay, breaking that down. It finds projects P.
Right, projects P that contain a log4j jar file, but where the version isn't one of the patched ones.
Now, you could do something similar in SQL with joins and where clauses, right?
You could. You'd use select, join, where. But the Mangle version isn't just a query. It's a named rule. Projects with vulnerable log4j. It encodes the logic, not just a one-time search. It's reusable knowledge.
That reusability is a big plus. But what about that contains jar part? Dependencies can go deep, right? Nested dependencies.
Absolutely, and that's where the recursion really shines. You can define contains jar recursively, like jar j contains jar p name version, contains jar jur directly, p name version, that's the base case, and then contains jar p name version. Project depends, PQ, contains jar Q name version.
So if project P depends on Q and Q contains the jar, then P also contains it indirectly.
Exactly. It walks the whole dependency tree no matter how deep. Try doing that elegantly in standard SQL. It's much harder. You end up with complex loops or self-joins. Mangle handles it naturally.
Okay, that's impressive for dependencies. What about other complex data? Like knowledge graphs where things are connected in all sorts of ways.
That's another strength. Mangle isn't limited to just binary relationships, like A depends on B. It can handle arbitrary N-ary relations.
N-ary, meaning relations between more than two things.
Right. Think person A bought product B from seller C. That's a ternary relation. Many systems, like some description logics, struggle with anything beyond pairs. Mangle handles structured data and these complex relations easily. So yeah, it's very well suited for modeling rich domain knowledge or complex knowledge graphs.
Sounds incredibly versatile. And you mentioned it's open source.
Correct. It's out there on GitHub, implemented as a Go library, so developers can experiment with it or embed it. It uses the Apache 2.0 license, though it's important to remember the disclaimer. It's not an officially supported Google product.
Got it. So wrapping up, Mangle seems like this really sophisticated tool. It combines Datalog's deductive power, especially recursion, with practical features. Great for complex, interconnected data.
Definitely. It lets you encode logic and handle relationships like those deep dependencies or N-ary connections in a way that's often much cleaner and more reusable than traditional methods like SQL.
It really changes how you think about querying data.
It does. Which leads to a final thought. Given Mangle's knack for modeling these intricate relationships and handling recursion so well, where else could this kind of deductive approach make a big difference? Think beyond software or knowledge graphs. How could it change how we query, maybe even understand other complex systems? It opens up some interesting possibilities.